Hey again everybody, and welcome to the third part of the Arduino Starter Kit. This time we're dealing with the levometer, which is pretty cool. So, yeah. With all this stuff, I managed to find the bit that's the most important here, and this is a temperature sensor. Now, just so we'll skip to the disappointment right now, it's not actually going to measure love, it's just going to measure your temperature. I know, but having a chapter titled Thermometer probably wouldn't be as exciting. What is kind of exciting is that you're actually using an Arduino to actually measure temperature in the first place. So how does it work? Well, let's take a look. So the first thing you got to do is, as you can see from the instructions, you wire the temperature sensor into your breadboard. It's got 3 pins in it. You hook one pin to voltage, the other pin to ground, and the middle pin you hook into the Arduino itself. In this case, you hook into A0. Now, up to now, we can press whether a button is down, whether it's a 1 or a 0. But with A0, with the analog input, it just doesn't measure whether it's 0 or 1, but it can measure whether it's 0, 1, 2, 3, 4, 5, 6. In this case, all the way up to 1024 or 23, one or the other. The point is, that's what we're going to do right now to measure it. So we go back to our previous experiment, and as you can see, once again, it's still working fine. And it's nice that it's still working fine, because we are now going to just tear it apart. There we are. Yeah, sorry. We'll use some of these parts a little later on, because they are 1 or 2 LED lights, but for now, there we are. Out with the switches, out with these connection cables, and out with this little resistor, the pull down or pull up resistor. I never quite didn't manage to figure that one out. And and out with this little thing. So the way the thing says is, so we got it more or less free. As you can see, the positive is still on the left and the negative is still on the right. So we split these up slightly, as you can see, and then we just plop it down there in the first 2. Now we just need 1 or 2 small little connections to connect them through. There we are. This is the connection that goes from positive. Yeah. Okay, so this is the connection that goes from the... Yes, that's row number 2, which is the first side, and the next going, into there. And next is we want to make the connection from number 4, which is the negative side, and go straight into negative. So what's happening now is that a voltage is passing through it. Now remember what I said earlier about, you don't want voltage going directly to current, directly, you want there to be something here. That looks confusing, so I'm just changing this just so that it doesn't look like I don't literally have cross wires, even though they're insulated cross wires. There we are. So positive to this side, negative to this side. So the idea is that the voltage goes through here, and I said you shouldn't have them directly connected, but don't worry, this actually has a resistance. But here's the clever thing. It manages the resistance according to the temperature, and the key thing is that when you press this, it's a different value comes out of the middle pin. So let's hook this one up to the middle pin, and the other side up to A0, and it's just falling short. Okay, don't worry, I've got longer ones. Well, I mean, I've got it, but the kit supplies the longer ones. So 1 in 3, which is the middle one, and the other in A0. Okay, now there's more to build, as you can see from here. There's stuff involving lights. But now that we've got this one done, let's just skip straight to the dev environment. Okay, so here's our development environment once again. If we now showing the ones from the last experiment, if we double check, yep, it's hooked up to the right board and the right port, and it's asking me, bugging me for updates, because everything bugs you for updates these days. Now, rather than just type in everything exactly as we did before, I'm just going to quickly skip to analog input, one of the example things that comes with Arduino. Now, once again, here's a lot of stuff about all the people who worked on this. Thank you very much, Tom Egoe. I'm just deleting you, not because I take credit, but because I want more space on the screen so I can show you this. And look, it looks pretty straightforward. So first of all, we set sensor pin to A0. Now, if you remember, that was the pin we attached the middle pin of the temperature sensor to. Then there's LED pin, but of course that's not what we're talking about right now, so I'm deleting that. So LED pin to output. Okay, never mind. We don't need that. There, it's obviously doing an LED thing right now. Okay. Okay, it looks like I shouldn't have done this. Let me just quickly get to the real meat of this. There we are. What happens is we got a sensor pin at A0, and then over here, everything, we do an analog read. And this reads sensor pin, which is A0, and stores it in sensor value. But how do we actually see what this value actually is? Well, thankfully, and examples in the source code are included in the book, there is a way called serial that you can actually be able to read these values and see them within your computer themselves. This is great for debugging. So serial.begin 9600, that's the rate or something, and then we go down to where it says serial thing, and then we go serial.println, then it's sensor value, and then we just better do a delay, because otherwise it'll just be spitting it out so fast it'll be really, really annoying. Yeah, delay. Let's say 1/4 of a second. Okay, without further ado, first of all, let's actually save this. Save as love meter, and then, and I'm pretty sure I spelt meter there. I misspell meter every single time. Now it's running. Now, there's no point switching the camera back to the board now. Well, there kind of is, but nothing's happening. It's just a single bit of hardware. But if I go to serial monitor, which is here, aha, look at this. Now, what is going on here, you say? Well, every 1/4 of a second, it's actually reading it, the voltage of the middle pin. As you can see, it's 146, which to me means absolutely nothing. But let's see what happens when I put my finger on top of the temperature sensor, which I'll do right now, and you'll have to take my word for it. Okay, it's not really... Okay. Okay, now I'm pinching it with both fingers. Yeah, it's going up to... Yeah, it actually is working. We're now in the 1600 and 165 range sort of thing. So now I'll release it. Okay, usually it takes a while to calm down, but it's going down. Okay, so this temperature sensor isn't exactly the fastest, and I assume because when you heat it up, it then still detects high values. But you can't deny that it is actually working. Now, that's the first start, but is there a way we can actually get more interesting numbers out of this? We've already printed out the sensor value, but convert the IS. So that's the sensor value, the raw sensor value. But there is also the actual voltage. So we can actually calculate the voltage by going float voltage. Float is just like a number with decimal points in it. Voltage, which equals sensor val dash 1024. That's its maximum range. 0.0. 0.0 makes you know it's a float. Then times that by 5. This will let us know exactly what the voltage is. But of course, you know, we want it actually to look nice. So what we do is click sensor print sensor value. Instead of doing print, we go print line. We do print serial.print, and then we go in, and then it's ln, and then it's voltage, and then for neatness we just copy this and do sensor value. Now this is kind of important because these three are just simple print statements, but this is print line, so that way it'll all appear on the same row unless I make a mistake. Yeah, there we are. Okay, let's take a look at the serial monitor. Okay, so right now at 147, it's volts. It's 72 volts, and when I put my finger against it, as you can see, the volts are going up. the heat from my hand is actually making the more voltage come out of the center pin, and it's being picked up. So basically, the heat from my hand is having a physical electric change in the environment we're doing, and that's what we're taking advantage of. Indeed, that's exactly what the whole point of it is. Now, it seems to say there's a way of converting this to actual, degrees Celsius. So I'll type it in. I'm a little skeptical myself. Let's see. Celsius. Oh yeah, I got to take out that int. And then let's see, serial.println, and then, oh right, we need to actually determine the temperature. Float temperature equals, and I'm just typing this right from the book here, voltage minus 0.5 times 100. So I assume this is the specs of the device. Someone said a while back there's a difference between precision and accuracy. Precision means it'll measure tiny changes like from 0.1 degrees, but accuracy will determine whether it's actually the temperature reading gives as close to what the actual temperature is. So regardless of that, let's see what this does and if we can get an actual temperature reading. So I don't know how. I think it's about 20 degrees Celsius in here, 24, that sort of range. Let's see if that's what we get. Oh yeah, game on. That is actually pretty close to, I think, what room temperature is even. It's jittering around by about a degree, which is slightly annoying, but that's fine. That is good. That is good. That's good. Now I'll put my finger on it again. Yeah, there we go. 23, 24, 25, 26, 27, 28, 29. I'm almost getting up to 30 degrees now, of course. Human body temperature is, I believe, 37 degrees Celsius, but it's hard to get it up to that just by touching it. So that's good. This means that it's, and as you can see now, it's going back to 27 and 26. That'll return basically to room temperature, which is about 22. So that's good. That means this thing is working. I apologize for my use of profanities. So this means that we can actually do some stuff with this. So what sort of stuff do we ask? Well, what we can do is we can actually get LEDs to light up. Now I could go and back to this and wire up all the LEDs and then go back to this, but I think I'll just code in the LED code thing right now. So what we want is a temperature. Yes, that's right. What we want to do is, the idea is we'll have 3 LEDs, and by default all of them will be off, then one will be off, then the second one will be, then one of them will be on, then the second one will be on, then all 3 will be on. So we have to decide, what sort of thing we want to go for there. So let's see. They say first of all they say set a baseline temperature. So we'll set the baseline temperature at we'll set the baseline temperature at about 20, yeah, like it is. Const float. Equals 20.0. Actually, I think I'll raise it up to 22 just to be on the safe side. So that's the baseline temperature. That's basically the room temperature. So what we're going to do now is set up the pin modes. Yes, there we are. So we're going to set them up from pin number 2 to pin number 5, and we're going to do it with a simple for loop. Int equals pin number. You know what? Actually, I'll just keep things simple. Pin mode to output. I could go through the complexities of how a for loop. Actually, a for loop really isn't that much complex. It just lets you go over. But I'll just do it like that for now. So that's setting our pins to those numbers. And now here is where we go. If temperature is less than baseline temperature, then we set all 3 LEDs to 0, basically. 2, 3, 4. You know, actually, yeah, there's a better way I can do this. Yeah, I know. No, we'll do that the long way, and then I'll show you a shorter way of doing it. So, if that's the case, then do that. Else, otherwise, so that's the else statement, if temperature is less than baseline temperature plus 2, and temperature, oh yeah, sorry, if it's greater or equal to baseline temperature, and temperature is less than baseline temperature plus 4, then we set one of the LEDs to high. Oops, sorry. So that turns on one of the lights. And you can sort of see where we're going from here. It's here, if it's greater or equal to 4 and less than 6, then we set 2 of them to high. And if it's greater than 6, then we just set all of them. So therefore, this means about 28 degrees Celsius. Yeah, because in order, I'll have to raise it to about 28 degrees Celsius, because the baseline temperature is 22 plus 6, 28. And that's will get all of the 3 LEDs jigged up. Now, it's suggesting I set the delay to 1 rather than 4. I'll split the difference. I'll set it to 10, so it's pretty fast, but not too fast. I don't want to, even though the book says it's okay, I don't want to just go completely crazy with this. And yeah, I think that's all the code I wanted. There was one thing I want to do. Technically, I could create a new little function here and then pass it a number, and it'll set the, you know, like say set level, and you press it as 0 and it'll automatically do all this. But I think I'm going to save it for now. That's more coding, and I think we'll just focus more on the wiring just for now. So let's go back and get this all wired up. Okay, so we just need to get them wired up. It's pretty simple as before. Essentially, we are sending the voltage from the 3 pins, 2, 3, and 4. We send it to the positive thing of the LED, and then we just have a resistor coming from the negative back to base. So let's. It's pretty much like what we did last time. Pretty straightforward. So first of all, let's set up the LEDs. There we have it, positive on this side, and then yes, this is going to be 2, 3, and this is going to be 4. 4 hooks up to this. Then the resistor goes from the pin to ground. Yeah, there we are. One to ground and one to there. Now we set up the second one. Once again, remember, longer one is positive. Set up 1 to positive, and the other 2, this one would be 4. Yep, that makes sense. And one from the ground to the ground via a very small enough resistor, actually. 220 ohms is the correct thing. Yes, that's right. These are measured with ohms. You know, I may, and I have referred to them as volts, but volts is volts. These are most definitely ohms. 220 ohm resistors. And this one goes into 2. And let's get that 220 ohm resistor going from the negative pin of the thing back to the negative there. Okay, that looks like it works. Okay. Did I press upload in the code? Give me just 1 second here. I think I may have written out the code and not actually uploaded it, so I'll just press the same button you saw there earlier. Oh, no wonder, there's a slight error in my code. It didn't compile. Expected, where is it? Yeah, okay, I just didn't put a semicolon at the very top of my file, so we'll just pretend I did. Oh dear, it's working already. Okay, that's nice. I guess 220 was kind of low. It was already. So let's put my finger on this and see what happens. Oh, okay. Okay, the middle one doesn't seem to be working, and I don't know why. Let me just put the middle one to a voltage and just see if that gets it going at all. Okay, so it goes. Okay, now it's working. Yeah. Okay. Okay, cool. So it's at 3, and if I put this, it should heat it up so it goes. Ah, there we are. So it's all 3 now. Maybe it was just. I guess it was just a loose wire or something. Maybe something was making contact. I think. So there we go, and now it's going down again because I'm not touching it. Cool down. I should grab some ice. No, actually I should not grab ice. Mixing ice with this is probably a bad idea. Okay, so there we go again. Okay, I'm going to change the baseline temperature up by a single degree. You've already seen it has 22. Now I'm going to change it to 23. And it's done uploading. Great, now they're all off. This is the good way of doing it. And I'll put my finger in. Oh, there it went up. There it up. That's it. This is literally a real measurement, a real temperature measurement, showing exactly what the temperature is. Well, not quite, because after I heat it up, then it takes a while to restore back to its base temperature. But there you go. Okay, give me a second. Okay, there we are. There we are. And just a bit more. Come on, you can make it. You can make it. There we are. There we are. That is fantastic. The Arduino using a temperature sensor module here to just give us an LED readout of how hot we are. And I already know I'm pretty hot. Yeah. Okay. The book suggests that you cut out cardboard style enough, you know, do a whole little craft, sort of like what we did with the spaceship, so that you can put some lips there and people touch the lips and then they see how much in love you are or whatever. We are not going to do that, but fear not, because after this chapter we will have another one called the color mixing lamp, and this one's actually pretty cool. Well, I mean, they're all pretty damn cool. I'm just saying this is also a cool one. So there you go. This is analog, temperature, love, whatever, sensing, and see you next time.